Earthquakes and volcanoes demonstrate nature's awesome powers. In the past 100 years, earthquakes and volcanoes have claimed over 1 million lives and destroyed hundreds of billions of dollars worth of property. What causes the Earth to shake and erupt with such uncontrollable fury? Earthquakes and volcanoes occur because the Earth's surface is changing. For billions of years, the Earth's base has been shaped by earthquakes and volcanoes, and the process continues today. The changes are probably no more violent or rapid now than they have been in the recent past. The difference is that we are here to witness them. Right now, as you watch this, the ground beneath your feet may be moving slightly. According to geologists, scientists who study the Earth's structure, the Earth's surface consists of about a dozen large sections called plates. These plates move slowly. Plate movement plays a key role in creating earthquakes and volcanoes. So let's take a closer look at why plates move. The Earth has several layers. At the center is the core, which is made mostly of iron and nickel, and is very hot. Surrounding the core is the mantle, made of minerals that are the building blocks of rocks. The mantle is hot enough in places to melt the minerals. Atop the mantle floats our crust, made of solid rock cooled from the mantle. Soil and water coat the crust like a layer of paint. Compared to the core and mantle, the crust is thin as an eggshell. Across the continents, the crust averages about 30 miles thick, while under the ocean, it averages about 6 miles. The mantle slowly moves as hot, thick, gooey, melted, or molten materials circulate up and down. The flow of the molten mantle moves the plates. Some of the plates travel about an inch per year, which is roughly the rate your fingernails grow. The fastest plates move perhaps 3 or 4 inches a year. This may not seem like much, but in 100 million years, even the slowest plate will travel 1,500 miles, or halfway across the North American continent. The plates head in a variety of directions. Some pull apart, others collide. Nearly all earthquake and volcano activity occurs at the boundaries or edges of plates. One of the most famous earthquake regions lies near the coast of California in North America. Here the Pacific Plate heads northwest, while the North American Plate travels southwest. The plates meet in a glancing blow called a strike-slip fault. The plates have cracked into a web of fractures, especially along the edges, called fault lines. Earthquakes occur along fault lines. Seismologists, scientists who study Earth movement, estimate a couple thousand earthquakes occur in California every year. Fortunately, few are strong enough to be felt by people, let alone cause damage. For the most part, plates slide by each other without notice, except by the seismologist's special equipment. Once in a while, though, the movement is not smooth. Deep underground, parts of the plate may stick to each other or get squeezed. Then plate edges stretch, bend, or compress. Though solid rock appears hard to us, under the Earth's immense heat and pressure, it can behave like plastic. As rock gets reshaped, it may store potential energy, like a spring or rubber band. some of the force applied to reshape it is still there, waiting to get released. Major earthquakes build potential energy for hundreds of thousands of years. When the crust can distort no more, it snaps. And the earth shakes. An earthquake usually begins miles underground. The site of first movement is called the focus of the earthquake. The point on the Earth's surface above the focus called the epicenter. The epicenter usually receives the strongest shocks. When the rocks at the focus snap, they jump into new positions and release some of their stored potential energy, sending out vibrations or shock waves we sometimes call tremors. The shock waves coming from the focus do not all travel at the same speed. Also, they may bounce or ricochet when they meet obstacles, such as the core, the mantle, or even the surface of the Earth. The worst earthquake damage usually occurs in areas where buildings sit in loose soil rather than on solid rock. This may be dozens of miles from the epicenter. The loose soil shakes and jiggles like a bowl of gelatin, multiplying the stress on buildings. Collapsing buildings can be deadly. Scientists and engineers have learned much about building safe structures in earthquake-prone areas. Still, no building can be made entirely safe, and the need to build in risky places increases because of our growing human population. In many places around the world, people also live on the slopes of volcanoes. When massive explosive eruptions occur, they can bury nearby homes and villages in ruins. Fortunately, the locations of most volcanoes is fairly well known. A map of volcanic areas is similar to a map of earthquake regions, because both occur chiefly along the boundaries of plates. In fact, earthquakes and volcanoes often occur in the same place, but not always. One especially active volcanic region surrounds the Pacific Ocean in a line that stretches from the tip of South America to down the coast of Asia. This is called the Ring of Fire. Here, plates collide, and the thin Pacific plate gets pushed down below the thicker, heavier continental plates of North America and Asia. This is called the subduction zone. As the ocean plate is pushed under, it melts because of friction between the plates and the high temperature of the mantle. The melted plate forms magma, which is melted mantle material that resembles lava. Generally, magma stays in the mantle, but at faults and other weak areas at the crust boundaries, it can sometimes erupt. The erupting lava may pile up on the surface of the Earth, forming a volcanic cone. Around the world, some volcanic cones have not erupted or changed much in thousands of years. We call these dormant or extinct volcanoes. If a volcano has a historic record of eruption, but not a recent one, we call it inactive. An active volcano is one that has recently erupted or appears likely to do so in the near future. Volcanologists, scientists who study volcanoes, look for signs of activity, such as a change in the slope of the cone or an increase in its soil or water temperature. So far, however, predicting eruptions is an inexact science. Volcanoes come in a variety of sizes, shapes, and styles. Some cones explode dramatically, a huge roar and belch a tremendous amount of material in a few hours. Others seem to have less force. The nature of the eruption depends on many things, including the type of lava. Lava is magma that reaches the surface. Some lava is thin and runny. Some is very thick. Also, some eruptions produce powdery rock called ash. Lava and ash from volcanoes soon cool and form rock. Different lavas and ashes produce different kinds of rock, though as a group, volcanic rocks are called igneous. Igneous means formed with fire. The rock creates new crust for the Earth. Most of our crust has a volcanic past, perhaps dating back billions of years. So today, at Volcanoes, we can see the Earth's crust grow. In a number of places, including the Hawaiian Islands, volcanoes erupt regularly. Here the lava flows to the sea, hardens, and adds to the size of the islands. Geologists believe the Hawaiian Islands developed from volcanoes at hotspots. Hotspots are long-time sources of magma and lava. As a plate moves over the hotspot, islands are deposited in lines like cookie dough on a baking sheet. Even more building occurs undersea at the borders between plates moving away from each other. Here, magma erupts at these undersea rifts to form new crust to fill the gap. Volcanoes play an important role in recycling Earth's rocks. At subduction zones, rocks from the crust melt into the mantle. Through eruptions, new rock emerges. The new rock brings fresh nutrients, minerals, and ores. Volcanoes also release some of the intense heat from the Earth's mantle. If we step back to look at the big picture of Earth, we see that earthquakes and volcanoes are but tiny steps in the sweeping changes occurring to the Earth's surface. Forces far stronger than we can imagine move pieces of the fractured crust in an ever-changing, rough-and-ready jigsaw puzzle. Unfortunately, at times our steel and concrete buildings and agile bodies and even our shrewd, ingenious minds are still no match for nature's awesome power.